There are a few different ways that you'll be able to verify your VRRP configurations. One of the ways is with show VRRP brief. Another way is with show VRRP. You'll also be able to use the running configuration to verify the configuration itself. And then you also can use ping and traceroute to verify connectivity. The thing I like about traceroute is you'll be able to trace the path that the client is using. So let me show you a trace rate now. If we do trace route on PC4 to 192.0.2.1, which is going to be the internet IP address, let's see what happens. We're going through 10.1.1.66. Now, who owns 10.1.1.66? If we type in show run interface VLAN 20, we'll see that this is 10.1.1.65, and on DSW2, show run interface VLAN 20, 10.1.1.66. So right now, DSW2 is the virtual router master for group 20, which is what PC4's subnet is based on. In this case, is the default gateway. Now, I want you to realize, though, that the IP address that is configured for interface VLAN 20 on DSW2 is the exact same address that is being used for the virtual IP address for the group, which means that DSW2 is going to be the virtual router master. And we can see from the output of show VRRP that we are the master. And our priority is 255. Now, the priority wasn't configured. If you look up here, it's not configured. So why is it 255? It's 255 because the virtual IP address that's being used is the exact same as the IP address of the interface. So it automatically increases its priority to 255, and since preemption is enabled by default, we have it becoming the virtual router master over DSW1. And this is what we want in our particular topology. We want DSW2 to be the master, and we want DSW1 to be backup. So if we look at show VRRP on DSW1, we can see it's the backup. But now, what happens if we end up in a situation whereby our timers are mismatched? If our timers are mismatched, our routers in the VRRP group don't technically see each other. They don't believe each other exists because we have a timer mismatch. As a result, they both become the virtual router master for the exact same IP address. And we don't want that to happen. If we go back to our topology, let's configure DSW2 with a different interval. Right now it's set up for a 1 second advertisement interval, which is the default, and so is DSW1. But let's change it now on DSW2. And when we change it, in global configuration mode, interface VLAN 20, we type in VRRP group 20 timers, and we say, ooh, advertised interval 2. So we're changing it to 2 seconds now. Look at the output of do show VRRP. Confirms that the advertisement interval is now 2 seconds. Therefore, the master down interval becomes 6 seconds. But if we go back to DSW1, you'll see a message saying, hey, yo, I just became the master for this particular VRRP group. And if we look at show VRRP, we'll see that we are the master now, as we are indicating here. But if you look at DSW2, we are the master as well. So what is the client using? Well, the client is using the virtual IP address of 10.1.1.66. But if we go to the client itself and issue a trace route, look at that. It's using DSW1 right now. This is not what we want. We don't want DSW1 to be the first hop for our topology. We want DSW2 to be the first hop. So as you can see, based on the fact that we have mismatched timers, we have 2 masters and the traffic is flowing through DSW1 instead of DSW2. So it's important, as you can see, that the timers match for VRRP. Do show VRRP. So I changed the timers back to 1. We go back to DSW1, you can see it's already demoted itself back to the backup. And if we go back to our PC and we issue the trace again, we'll see that we're going through DSW2 again. Group numbers have to match, and that makes sense. If we are part of a VRRP group, then every router has to be part of that same group, and that number represents the group, so we all need the same group number. If we don't have the same group number, it means that we're going to have different groups using the same IP address as the virtual IP address, which is not good because if our virtual router master that is currently being used by the clients goes down, there's really no other router for that group that can back up the clients because there's no communication between the different routers and the different groups. So to verify the group number, again, you can use the command show VRRP to do so. And you'll see right at the top, this is group number 20. And we go to DSW2. Show VRRP also indicates that this is group number 20. If you want to, you can use show VRRP brief. That's another option you have. If I can spell brief today. There, I still can't spell brief. There we go. Nope. I hope you're having a good laugh. There we go. We can see group number 20 there. But you can also see the state. The state is master on this one. And DSW1 would indicate group 20 in the output. And the state would be backup. The virtual IP address should match. It doesn't have to match. But if it doesn't match between all of the routers in the group, well, what are you going to put on the clients? What are you going to put on the clients? Right? Whose IP address are you going to use? And then once that device fails, the clients are still pointing to that failed IP address. So you're defeating the purpose of using VRRP. So within the group, let's have matching virtual IP addresses. But let's see what happens when they don't match. Right now on DSW2, we currently have 10.1.1.66 set up as the virtual IP address. Let's go over to DSW1 and modify that. Configure terminal, interface VLAN 20. We'll say VRRP group 20 IP. And let's give it the address of 10.1.1. Let's see, 65, 66. Let's go with 67 just for fun. Let's see what happens here. Notice that it was the backup for group 20, so it disabled itself, and then it started going through the election process. Hey, do we have anybody that's currently the virtual router master for this group based on this IP address of 10.1.1.67? And it says, no, there is nobody. So I'm making myself the master. So it's now the master, and DSW2, well, it's still the master as well, but for a different IP address. It's the master for 10.1.1.66, and DSW1 is the master for what? 10.1.1.67. So again, we have two virtual router masters. But what are you configuring on the client? You're configuring 10.1.1.66, because that's what our documentation says to do. So if all of a sudden our virtual router master of 10.1.1.66 goes away, which is DSW2, who's going to back it up? There's nobody there to back it up. Nobody. Because the clients are still pointing to 10.1.1.66, not 10.1.1.67. So it's important that we have accurate IP addressing on our routers participating in that VRRP group. And lastly, we see here authentication. So we can set up plain text authentication for VRRP. And it's important that the parameters match exactly or authentication will fail. If we go over to DSW1, let's set up an interface VLAN 20, VRRP group 20 authentication, and it's plain text is the only option I have. Let's set up a string of TSHOOT. If we go over to DSW2 and do the same thing, then we'll successfully authenticate. But notice already it says bad authentication from 10.1.1.66, group 20. Type 0. We expected 1. So we're expecting authentication. We're expecting plain text authentication. We're not getting anything from DSW2 because DSW2 is not authenticating. So what does DSW1 do? It promotes itself to the master. So if we look at the output of do show VRRP, we'll see that DSW1 is a master right now. And if we go to DSW2, do show VRRP, it's also a master. So we have two masters again for the exact same IP address because we misconfigured authentication. So it's important that we don't have two masters for the exact same IP address. If we visit our PC and we do a trace, we'll see that in this case, all right, we're going through DSW2 right now. But other clients might be going through DSW1. Other clients might be going through DSW2 and vice versa, back and forth. So we have to make sure that we accurately define the addressing, the timers, and authentication. So let's configure DSW2 here with interface VLAN 20, VRRP group 20, authentication, it's plain text, and we said TSHOOT. And when we do so, we should see that DSW1 realizes that DSW2 is the true master, and then it's going to make itself the backup router for the VRRP group. So if you ever see multiple virtual router masters in a VRRP group, double check your timers, double check your group numbers, double check that virtual IP address, and double check authentication. Any one of these could be the culprit for the double virtual router masters.